Good day, everyone. My name is Deslyn Pancho, leader of Group 6, and today I am going to talk about compound interest. So, do you have any idea about the compound interest? Well, let me tell you. Compound interest, in simple understanding, it is the addition of interest to the principal sum of a loan or deposit. In other words, interest on interest. It is also the result of reinvesting interest rather than paying it out. It was believed that it has been originated in the 17th century in Italy. Compound interest can be thought as of interest on interest, as I mentioned earlier, and it will make a sum of grow at a faster rate than simple interest. And it is calculated only on the principal amount. So, what are the important things that we should always remember about the compound interest? So first, compound interest or compounding interest is interest calculated on the initial principal, which also includes all of the accumulated interest from previous periods on a deposit or loan. Second, compound interest is calculated by multiplying the initial principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. Third, interest can be compounded on any given frequency schedule from continuous to daily to annually. Fourth, when calculating compound interest, the number of compounding periods makes a significant difference. So, how does compound interest work? So, compound interest is calculated by multiplying the initial principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. The total initial amount of the loan is then subtracted from the resulting value. So, here is the formula of compound interest. A for the future value of the investment or loan, including the interest, and then P, the principal investment amount or the initial deposit or loan amount, R for the annual interest rate or decimal, and the number of times that interest is compounded per unit. T, the time the money is invested or borrowed for. So, let's have an example. If an amount of $5,000 is deposited into a savings account at an annual interest rate of 5%, compounded monthly, what will be the value of the investment after 10 years? So in this case, we are just going to follow the formula, and our solution will be P equals 5,000 for the capital, R equals 0.05 because that is the decimal form of 5%, N equals 12 because there are 12 months in a year, and then letter T is 10 because it is 10 years. And then we are just going to follow again the formula, and we'll write it down as A equals 5,000, open, close parenthesis, 1 plus 0.05 over 12, and then open, close parenthesis again, 12 times 10. So the answer would be $8,235.05 thousand. So the investment after 10 years will be that 8,235 and 0.5 cents in a dollar form. So I hope you learn a lot.
Good day everyone. Today I'm about to tackle the compound amount. What is compound amount? Compound amount is total amount after the principal is compounded for a certain number of periods at a certain rate. This is the formula that we're going to use in calculating the compound amount, where A is equal to compound amount, I is equal to interest per compound period, P is equal to principal amount, N is equal to compounding periods. So for I, we have amount of interest rate divided by number of compounding periods per year, or R divided by N. To solve for N, we need to multiply the number of compounding periods per year and number of years, or N times T. What is compounding? Compounding is the process in which an asset's earnings from either capital gains or interest are reinvested to generate additional earnings over time. This growth, calculated using exponential functions, occurs because the investment will generate earnings from both its initial principal and the accumulated earnings from preceding periods. Compounding, therefore, differs from linear growth where only the principal earns interest each period. When banks or financial institutions credit compound interest, they will use a compounding period such as annual, monthly, or daily. Compound interest works on both assets and liabilities, while compounding boosts the value of an asset more rapidly. It can also increase the amount of money owned on a loan as the interest accumulates on the unpaid principal and previous interest charges. Take a look at this sample problem. Suppose you deposit 10,000 pesos in a savings account earning 6% interest compound annually. What is the compound amount after 2 years? So, to solve for I, we have R divided by N. Substitute the value to the formula and we have here the 0.06. To solve for N, we have R times T. Substitute the value to the formula, we have N is equal to. And using the formula, substitute all the value and we have the result of 11,236 pesos. Therefore, the compound amount after 2 years is 11,236 pesos. Let's move to another situations where Johnny borrowed 15 pesos from a bank with an interest rate of 5% compounded quarterly. What is compound amount after a year? So, I is equal to R divided by N. Substitute the value to the formula. We have I is equal to 0.0125. N is equal to R times T. 4 times 1 is equal to 4. Use the formula to solve the compound amount. So substitute the value. Then we have 15,764.18. Therefore, the compound amount after a year is 15,764.18 pesos.
Hello everyone, I'm Jella Palmer from Group 6. Now, I'm going to tackle future value. So what is future value? Future value is a value of a current asset at a future date based on an assumed rate of growth. The future value is important to investors and financial planners as they use it to estimate how much an investment made today will be worth in the future. Knowing the future value enables investors to make a sound investment decision based on their anticipated needs. However, external economic factors such as inflation can adversely affect the future value of the asset by eroding its value. Understanding the future value. The future value calculation allows investors to foretell or foresee, with different degrees of accuracy, the amount of profit that can be generated with different investment. The amount of growth generated by holding a given amount in cash will likely be different than if that the same amount were invested in stocks. Therefore, the future value equation is used to compare multiple equations. Determining the future value of an asset can be complicated, depending on the type of asset. Also, the future value calculation can base on an assumption of a stable growth rate. If money is placed in a savings account with a guaranteed interest rate, then the future value is easy to determine accurately. Types of future value. First, future value using simple annual interest.
The formula of simple annual interest is FB is equal to P times the quantity of 1 plus RT. P stands for initial principal balance. R is for rate. T is for time. Future value formula assumes a constant rate of growth and a single upfront payment left untouched for a duration of the investments. The future value calculation can be done one of the two ways, depending on the type of interest being earned. Second type of future value is future value using compound annual interest. The formula of compound annual interest is FB is equal to P times the quantity of 1 plus R divided by N raised to N times T. FB stands for future value, P for initial principal balance, R for interest rates in decimals, N stands for numbers of times that interest is compounded per unit, and lastly T for time. Compound interest or compounding interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous periods. The rate at which compound interest occurs depends on the frequency of compounding, such that the higher the number of compounding periods, the greater the compound interest.
So hello everyone, I am Yvonne and today I am going to talk about the present value. But before that, let me show you my objectives, conceptual framework, and overview about this topic. So what is present value? Net present value is the present value of the cash flows at the required rate of return of your project compared to your initial investment. It states that an amount of money today is worth more than the same amount in the future. In other words, present value shows that money received in the future is not worth as much as an equal amount received today. So how present value used? So present value is critical in many financial applications such as the valuation of pension obligations, decisions to invest in fixed assets, and whether to purchase one type of investment over another. The concept of present value is especially important in hyperinflationary economies where the value of money is declining so rapidly that future cash flows have essentially no value at all. So here's the formula to calculate the present value. Present value is equals to the future value times the quantity of 1 over the sum of 1 plus the rate of return raised to the power of periods. So here are the components in calculating the net present value. Present value amount or PV, future value amount or FV, length of time before the future value amount occurs or N, and interest rate used for discounting the future value amount or I. If you know any three of these four components, you will be able to calculate the unknown component. Why is it important? Present value is important because it allows investors to judge whether or not the price they pay for an investment is appropriate. It considers the time value of money, translating future cash flows into today's dollars. It provides a concrete number that managers can use to easily compare an initial outlay of cash against the present value of the return.
Good morning, everyone. I'm Joshua Malinaw, and our topic for today's report is all about effective interest rate. So before I start, here is the objectives and conceptual framework. So what is effective interest rate? The effective interest rate is the rate of interest actually earned on an investment or loan over the course of a year, incorporating the effects of compounding. An investment that has a stated nominal interest rate of 5% may actually have a higher effective interest rate once the impact of compounding is added to the calculation of interest. For example, the effective interest rate can be used to compare the return on a loan that compounds monthly to one that compounds quarterly, or to compare the return on the bond that was acquired at the discount from its face amount to one that was acquired at a premium. The effective interest rate calculation is 1 plus nominal rate, number of compounding periods, number of compounding periods minus 1, so equals to effective interest rate. An essential principle to be aware of when comparing the returns on financial instruments is that more frequent compounding results in a higher effective interest rate. Another principle is that a larger discount from the face amount of an investment results in a higher effective interest rate.
Hi, good day everyone. My name is Melinda Bit, and today we will discuss all about calculation of effective interest rate. The effective rate is a calculated through a simple formula. The formula is 1 plus I is equivalent of n raised to n minus 1. In this formula, R represents the state interest rate. I represents the number of compounding period per year. So, I give you an example of calculation of effective rate. Effective annual interest rate, 1 plus a nominal rate, number of compounding periods. So, raised to number of compounding periods minus 1 for investment. This is a would be 10.47% equals 1 plus 10% divided by 12 and raised to 12 minus 1, and for investment B it would be 10.36% and plus 1 plus 10.1% is 12 raised to 2 minus 1. That's it.